Hi, this is the work with. I'm studying in Institute of Aeronautical Engineering. I'm studying BTech first year Computer Science Engineering. Today we are going to I'm studying BTech first year Computer Science Engineering. Today we are going to discuss about parallel connection of resistors. Before going to the parallel connection of resistors, we should have some knowledge about resistors. Resistor. A resistor is a passive two-terminal electrical component that implements electrical resistance as a circuit element. In electronic circuits, resistors are used to reduce current flow, adjust signal levels, to divide voltages, base active elements, and terminate transmission lines among other uses. And actually, resistor is a device which is used to reduce the flow of current when current passes through it. Resistance is a phenomenon of uh, reducing the current. Resistor is a device. There are two types of resistors: four-banded resistor and five-banded resistor. We will mostly discuss about four-banded resistor. How to identify the resistor? There are certain values of resistors. To identify the values of resistors, we'll use the color coding of resistors. Components and wires are coded with the colors to identify their value and function. Resistor color coding uses color bands to quickly identify a resistor value, and its percentage of tolerance with the physical size of resistor indicating its wattage rating. Here we have taken considered into four banded resistors. Four banded resistors consist of 13 colors. Last three colors are used for tolerance. The colors used for tolerance are gold, silver, none. Gold is used for 5% tolerance, silver is used for 10% tolerance, and none color, no color, none. No, none means no color. No color is used for 20% tolerance. The 10 colors used are black, brown, red, orange, yellow, green, blue, violet, grey, and white. Okay, now we are assigning its value: black as 0, brown as 1, red as 2, orange as 3, yellow as 4, green as 5, blue as 6, violet as 7, grey as 8, white as 9. Okay, tolerance: brown, red, green, blue, violet are neglected. They are very less value, so that they are neglected. Okay, when we are writing the value of resistors, first two digits implements same color, same the digit we have applied, but in third color we need to use the multiplier value. It's simple. Into 10 power we have to write the number. In electrical circuits, resistors are indicated with this symbol. The units of resistance is ohm. The connection or combination between resistors is divided into two types: the series connection and parallel connection. Today we are going to discuss about parallel connection of resistors. In a parallel resistor network, the circuit current can take more than one path as there are multiple paths for the current. Then parallel circuits are classed as current dividers. Since there are multiple paths for the supply current to flow through it, the current may not be the same through all the branches in the parallel network. However, the voltage drop across all of the resistors in a parallel resistor network is the same. Then the resistors in parallel have common voltage across them, and this is true for all parallel connected elements. So we can define a parallel resistor network as one where the resistors are connected to the same points or nodes, and is defined by the fact that it has more than one current path connected to common voltage source. Then in our parallel resistor example, below the voltage across resistor R1 equals to voltage across resistor R2, which equals to the voltage across R3, and which equals to the supply voltage. Therefore, a parallel resistor network thing. This is given as. Actually, when the resistors are connected in parallel, uh, the current will be divided through each resistor, and the voltage across each resistors will be definitely same. Uh, when they are when the resistors are connected in parallel, the definitely the current through the resistors will be different. There is only one case when the current passes through the resistors in same, the two resistors in a circuit having same value when they are connected in parallel. If they are connected in series, same current flows through them and different voltage will be there. Actually, now we'll consider this example. We have taken R1, R2, R3, three resistors and 12 volt supply voltage. Therefore, current I is generated. I will be divided through each resistor. I1 as R1, I2 as R2, I3 as R3. But potential difference or voltage will be same at each resistor because because the potential difference between 2 points, the potential difference between two points is also known as voltage. Now we are going to calculate the equivalent resistance when the resistors are connected in parallel. When the reciprocal 1 by R value of individual resistance are all added together instead of resistance themselves with the inverse of the algebraic sum, giving the equivalent resistance as shown. Parallel resistor equation 1 by RT, T is the total resistance, RT is the total resistance, equal to 1 by R1 plus 1 by R2 plus so on 1 by Rn, etc. Now we will consider an example to solve it. See this diagram, two resistors of value are connected in parallel when therefore the equivalent resistors will be divided. When the resistance are connected in series, the equivalent resistors will be more than the resistor, more than the individual resistor value. If the two resistors are connected in parallel, the equivalent resistance will be definitely lower than the value of the individual resistance. If the two resistance or impedance are connected in parallel are equal and of the same value, then the total or equivalent resistance RT is equal to half of the value of the value of one resistor. Then this is equal to R by 2. For 3 equivalent resistors in parallel, R by 3. For 4 equivalent resistors, R by 4, and so on. Note that equivalent resistance is always less than the smallest resistor in the pattern network. So the total resistance RT will always decrease as additional parallel resistors are added. When a resistor is connected in series, the equivalent resistors will increase. Equivalent resistance increases. When the resistance is connected in parallel, the equivalent resistance decreases. Parallel resistance gives us a value known as conductance. Symbol G, the units of conductance being the Siemens. Symbol S. The units of conductance are Siemens denoted by the symbol S. Conductance is the reciprocal or inverse of the resistance. G is equals to 1 by R. To convert conductance back into resistance value, we need to take reciprocal of conductance, giving us then the total resistance RT of the resistance in parallel. These are various parallel resistor networks. To easily understand, we'll start from here. This point from this point there will be division of current. So we can say that these are two resistors are connected in parallel. When at particular node current divides between two resistors, then we can say that two resistors are said to be in parallel. There will be two or more than two resistors. From here point the current will be divided here. From this point, see here we have taken two resistors and current divided at particular node, but at this node the current will be divided into three parts because three resistors are connected to a single node. In fourth diagram also we can see that at this node current divided into three parts, but in the last figure at this node current will be divided into two parts. These are various parallel resistor networks to easily understand. Now we are going to do that. We are going to solve some examples. First question: find the total resistance RT of the following resistors are connected in parallel network. Here only given that they are connected in parallel. Okay. The easy method is to calculate by using equivalent resistance formula. There are three resistance connected in parallel. R1, R2, R3. R1 is equals to 200 ohms. R2 equal to 470 ohms. R3 equals to 220 ohms. The total resistance across two terminals A and B is calculated as 1 by RT equals to 1 by R1 plus 1 by R2 plus 1 by R3. By using this formula, we can calculate as 1 by 200 plus 1 by 470 plus 1 by 220 is equals to 0.0117. Now, reciprocal of this resistance is the equivalent resistance. We have actually derived it. 1 by 0.0117 is actually 85.67 ohms. Now we can see that the equivalent resistance is less than the value of individual resistance. As you compare equivalent resistance to R1, equivalent resistance only decrease lesser value. When we compare to R2 and R3 also, equivalent resistance has only lesser value when compared to these three resistors. Consider the following circuit, which has two resistors in a parallel combination. Now we are given two resistors in a parallel combination with supply voltage 12 volts. We don't need supply voltage, just we need to calculate the equivalent resistance. Using our formula for about two resistors connected together, we can calculate total circuit resistance RT as there are two resistors given and IT current generated I1, I2 are current divided. Uh, Supply voltage 12 volts, two resistance the value is 22 kilo ohms and 47 kilo ohms. Now we are going to calculate it by using the formula RT equals to 1 by R1 plus 1 by R2 because there are two resistance given. We can take LCM R1 into R2 by R1 plus R2. This is when we take the R1 and R2 as LCM. Now we can get it 1 by RT equals to 1 by R1 plus 1 by R2. 1 by RT equals to R1 plus R2 by R1 into R2. Now reciprocing the above equation will get total equivalent resistance R1 into R2 by R1 plus R2. R1 is 22 kilo ohms, R2 is 47 kilo ohms. By substituting these values, by substituting these values, we will get the equivalent resistance 22 into 22, 22 into 47 by 22 plus 47 is 14.9 kilo ohms. We will round it to the 15 kilo ohms. Another example, calculate the individual branch currents and total current drawn from the power supply for the following set of resistors connected together in a parallel combination. As we can see the diagram, he has given supply voltage 24 volts and 4 resistors with 4 different values connected in parallel combination, and IT is the current generator, is total current. Now we need to calculate total current in the resistor. Before calculating total current, we need to calculate the individual branch currents and we need to add it. You know that resistance is inversely proportional to current. When the resistance are connected in parallel, uh, definitely by using when the resistance is correct, by using KCL, we may calculate total current by using a particular nodes. At this node, ID equals to I1 plus I2 plus I3 plus I4. Okay, as the supply voltage is common to all the resistors in a parallel circuit, we can use Ohm's law to calculate the individual branch currents. Now we are using Ohm's law to calculate I1, I2, I3, I4. From the diagram, we can see that I1 is passing through R1. Therefore, I1 equals to supply voltage by R1. We are taking supply voltage as same because in the parallel combination of resistors, there will be same supply voltage throughout any resistor when connected in parallel. I1 equals to Vs by R1 24 by 10 ohms 2.4 amperes. I2 is equals to Vs by R2 equal to 24 volt by 20 equal to 1.2 amperes. I3 is equals to Vs by R3 24 by 30 0.8 amperes. I4 equal to Vs by R4 24 by 40 0.6 amperes. Now we have successfully calculated the individual currents by using KCL. That in the total current IT flowing into the parallel combination resistance will be IT equals to I1 plus I2 plus I3 plus I4, sum of all the wasted currents, because when we used KCL at this node, IT is equals to I1. IT is only current coming inside, and I1, I2, I3, I4 are four currents going outside. Therefore, IT is equals to I1 plus I2 plus I3 plus I4. IT is equals to 2.4 plus 1.2 plus 0.8 plus 0.6. Now we are getting IT as 5 amperes. This total current of value 5 amperes also can be found by verifying equivalent resistance of the parallel branch and dividing into the supply voltage Vs as follows. The total circuit current value of 5 amperes can also be found and verified by finding the equivalent circuit resistance RT of the parallel branch and dividing into the supply voltage Vs as follows. And this is the one method to calculate the total current throughout the circuit, and we can calculate it by another method also, by calculating equivalent resistance and dividing by the supply voltage. Equivalent circuit resistance. We know that by using the formula, we can calculate 1 by RT equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4. 1 by RT equals to 1 by 10 plus 1 by 20 plus 1 by 30 plus 1 by 40. 1 by RT equal to 0.1 plus 0.05 plus 0.033 plus 0.025. The total is 0.2083. RT is equals to 1 by 0.2083 is equals to 4.8 ohm. The equivalent resistance of this circuit is 4.8 ohms. We can calculate equivalent resistance without using formula. So now we need to go back. into the circuit. By observing the circuit, we can see that R4, we need to start calculating from the opposite end of the supply voltage so that we can calculate in the easy way. Now, before going to the opposite end, R4, uh, going to the opposite end, R4 is it starting, we need to calculate. R4 and R3 are in parallel. By calculating R4 and R3, we'll get an equivalent resistance there in parallel. 1 by R1 equal to 1 by R equal to 1 by R1 plus 1 by R2. We'll get the equivalent resistance between R3 and R4. Now that equivalent resistance and R2 are in parallel. After calculating by using the formula 1 by R equals to 1 by R1 plus 1 by R2, we will get the equivalent resistance of R3 and R4 and R2 as one more equivalent resistance. Now final equivalent resistance is parallel to R1. Using formula 1 by R equals to 1 by R1 plus 1 by R2, we will get the equivalent resistance of the circuit. After finding the equivalent resistance, the circuit will be minimized. There will be only two terms. There will be only single resistor expressed with the four resistors. And the current flowing in the circuit will be IT equal to Vs by RT. Now, by using Ohm's law, we can calculate 24 by 4.8 is definitely 5 amperes. We are going to do these examples. Now, find the total resistance RT of the following resistors connected in a parallel network. In the circuit, there are three resistors connected in parallel connection. We can say that they are connected in parallel network. We also given, but if we not given when they are connected in parallel, we can verify that when current is passing through the A. When the supply voltage is given to this circuit, the current will be divided at the A and B. Therefore, when the current is divided, we can say that R1, R2, R3 are in parallel connection. R1 equal to 200 ohm, R2 equal to 470 ohm, R3 equal to 20 ohm. By using this formula, 1 by RT equal to 1 by R1 plus 1 by R2 plus 1 by R3, we can calculate the equivalent resistance. 1 by 200 plus 1 by 470 plus 1 by 220. 1 by 220 is equals to 0.0117. Therefore, RT is equals to 1 by 0.0117 equal to 85.61 ohms. Or we can calculate by using opposite end theorem. R3 is parallel to R2, therefore we will get the equivalent resistance when they are in parallel by using the. We can calculate the equivalent resistance by using formula 1 by R is equals to 1 by R1 plus 1 by R2. After calculating the equivalent resistance between these two, we need to do it with the R1. R1 and equivalent resistance between R2 and R3 are in parallel, and by using the formula, we will get R1 1 by R equals to 1 by R1 plus 1 by R2. We may calculate the equivalent resistance once again. In this circuit, we will get again equivalent resistance same as 85.67. We can solve it by n number of methods, but we will get the answer same. Equivalent resistance in the circuit will be same when resistors are unchanged. Another question. Second question. Consider the following circuit which has only two resistors in a parallel combination. This is the easy one. 12 volt supply is given. 12 volt supply is given. We need to calculate the equivalent resistance by using the formula 1 by R1 by R equals to 1 by R1 plus 1 by R2. We will calculate it by taking the LCM. R1 by R equals to R1 plus R2 by R1 R2, and by reciprocating by inversing the equation, RT equals to R1 R2 by R1 plus R2. Substituting these values, we will get the equation. We will get the answer as 14,985 ohms or 15 kilovolts. 15 kilovolts. Or for finding the current, we need to do it by using Ohm's law. We can calculate it by I by V I equals to V by R equivalent. Equivalent is 15 kilo ohms. 12 by 15 kilo ohms is the total current, and we can calculate I1. I1 is equals to 12 by 22 kilo ohms, and I2 is equals to 12 by 47 kilo ohms. Individual currents passing through individual resistance. Calculate the individual branch currents and total current drawn from the power supply. For the following set of resistors connected in parallel section. In the circuit, they are given R1, R2, R3, R4 for resistors connected in parallel. We can see that current is dividing IT as I1, I2, I3, I4. We need to calculate IT. So supply voltage given as 24 volts. R1 equals to 10 ohms, R2 equals 20 ohms, R3 equals to 30 ohms, R4 equals to 40 ohms. By using ohms law, we can calculate I1, I2, I3, and I4. V by R supply voltage will be same to the throughout each resistors because the resistors are connected in parallel. After finding individual currents, we need to sum up by using the KCL. At node A, we can see that only IT is the current going out, going in. I1, I2, I3, I4 are the currents going outside. By using KCL, we can write the equation that IT is equals to I1 plus I2 plus I3 plus I4, and we will get the total current. We can calculate it by another method also by using the formula. We can first calculate equivalent resistance. 1 by RT equals to 1 by R1 plus 1 by R2 plus 1 by R3. After calculating equivalent resistance, we need to divide it by voltage. Voltage by supply voltage by equivalent resistance, we will get the 5 amperes. Thank you.